Hi everyone, my name is Ian for the third time tonight. Today, we're going to talk about some features from TypeScript 5.1. And the first one I'll cover here is typeroots are consulted in module resolution. So what is module resolution? Just quickly, say you're importing foo from foobar. TypeScript needs to know what the types of foo are so that it can figure out whether you're using it correctly. So it has to find the foobar module, and depending on the module system you're using, that could be in different places. There's a module resolution mode or a setting that you can change that sort of tells TypeScript what rules it needs to follow in order to find the module. But if you want to learn more about this, there is a Michigan TypeScript video that does a deep dive onto module resolution. So then the other piece of this is, what are typeroots? And I thought I knew what typeroots were when I was getting ready to give this talk, and I was using typeroots, and I learned they're a little different from what I expected. But sort of as a background, like TypeScript, it can look for type definitions in a different folder from the package itself, right? This is how definitely typed works. If you've ever imported a @types/react or node or whatever, right? Those are put in a separate place in your node modules from the thing itself, from React, from whatever. And so it already has this idea of like looking in a different place to find the types. By default, it does look for @types in your node modules. That's where all the definitely typed types go. But if you specify a directory in your typeroots, it goes there instead. And so, if you don't want it to look in node modules @types, then you can make a typeroots, and it will look in there instead. And this is the piece that I learned, is it seems like it's actually mostly like for legacy pre-2.0 TypeScript before they had definitely typed. I think it was called typings at that point. So it was kind of like for that migration. And it also has been used for // directives. So if you're manually creating a .d.ts file, you can reference other types this way with this special kind of comment, and it will look in your typeroots. Dimitri?
In that third point, if you say node modules / my very cool, super awesome types that are better than definitely typed / my library, would it look in those two places? Or is this a way with, you said specifying a directory, can you override @types? You see what I'm asking? Do you have to also put @types if you
do, yes.
Oh,
so
okay.
Instead is very keyword.
Yes, instead, exactly. So if you don't put @types there, it won't look in @types anymore.
Right,
although, we'll get there. So I think this is mostly, again, just for these //. It doesn't necessarily impact the way that if you're importing a type and it's looking for the modules, except for things have changed. So in 5.1, if TypeScript looks for the type definitions for a module and it can't find them by its normal process, it will now look in typeroots. So it didn't used to do that for your imports. It was really only the //. Now it will look for it in when you're importing things. And this will get important after we go through my next video, where TypeScript is no longer like defaults to falling back to your node modules no matter what. Like it used to do that. It doesn't anymore. So with these two changes, they kind of play together. And you'll see more about that in the next video. The other thing you can do now is declaration merging for files in typeroots. So declaration merging, if you're not familiar, this is, say, I gave the example of TanStack table because it does a nice job of this. It has this interface of column meta, and it sort of like gives you an opportunity to add your own metadata to your columns. But it doesn't know what they are, but it needs to be like very strongly typed so that if you do something incorrect or whatever, like it wants to alert you. And so you can, in your own file, import and then declare the module name and then specify whatever properties you want in that interface, and it'll merge that together with what TanStack table has by default, right? This is a nice way to extend libraries or packages. So now, instead of just TanStack table, which lives in your node modules, You could import from another file in your typeroot and extend that. I don't know why you'd want to. Can anyone here think of like a use case for extending something that you have in your typeroots? Like you've already written it in your typeroots, so presumably you'd be able to just change it there, but.
So other ecosystems don't have, so like when Go introduced modules, they made sure that there's not just their module system, like we have definitely typed and there's no competitor to definitely typed, but if there were a competitor to definitely typed, then what you said wouldn't be true. What actually in that situation, you would have both. You would have definitely typed and the other thing that's a competitor to definitely typed, and you may not have written either of those two things. That would be my explanation. I mean, I bet they were aware of other languages, and I think Rust has a similar thing as well. You don't only have to get packages from Cargo, you can get them from other places. It's just that everybody does because it works, but engineers always trying to plan for contingencies.
I will say in the comments on YouTube, if you have a use case for this, I'd love to hear, leave a comment, let us know why you're excited about this change.
Yeah, I know at least one place in my code base at work, our code is using something that has definitely typed types, but there's like a bug in it that's been out there for 5 years that they haven't fixed. And so we have something exactly like this that's declaring a module that's then overriding the broken definitely typed type.
Yeah, that's sort of the traditional use case for doing this declaration merging, or there's a module augmentation where maybe you want to like add new features to something. You can kind of do that this way too.